Greetings. This time we're going to take a look at some source code with respect to C++ classes. We'll take a look at a very simple class that defines a sphere, and then we'll extend that into a sphere with color, and then see how we can use those different versions of a sphere in a program. So to begin with, let's take a look at the files I'm talking about. And in the review folder of the lectures repo, you'll see that there are a number of files that have the name sphere in them. So we'll begin with sphere.h, which declares the sphere, the structure of the sphere class, if you will, and then we'll take a look at sphere.cpp, which provides the implementation details behind that declaration. And then we'll take a look at the sphere in color.h to show you how we can extend a class, that is to specialize a class, and again looking at the implementation details in a separate implementation file called sphere-in-color.cpp, and then finally take a look at a file called sphere-driver.cpp, which shows how we can utilize these classes that we've devised on our own. So here's the sphere. So a couple of things here. I've talked about this in lab, and I just want to remind you that lines 3 and 4, and down here at the very bottom, 74, all put together create what I call a multiple inclusion macro guard. Alright, what it's doing is it's a guard that is created with a set of macros, the pound if not defined, impound define, impound end if, and we use these to define basically labels, and we use them to prevent a file from being included multiple times. So for example, sphere is going to be included in the extension of the sphere, and it's going to be included again in a sphere driver, test program. So if we have that same file included multiple times, we run the risk of having the sphere class being declared in multiple places within the same scope, and of course that would create an error. So we use this guard to help us to keep that from happening. Okay. Now, inside the macro guard, then I have well, first of all, I declare a constant called pi, and because it's declared outside of the class, it can be used basically anywhere within the class, and any file that includes this header file will have access to this named constant called pi. The class itself begins with line 9, and it uses the keyword class, and then we come up with our own name, in this case a sphere, and then we identify two different sections, a private and a public section. The private section is used to encapsulate data and is in essence hidden from any client of a sphere class. Anything that wants to use a sphere that isn't a sphere itself cannot see this attribute called the radius. But again, since it is inside of the sphere, so to speak, any of the methods that we implement in the sphere class will have access to the radius. And what we're doing here is the sphere is, in some sense, defined by its radius, and so we have an attribute to capture that aspect of a sphere, its radius, in a variable, or an attribute as it's called, the radius. Sometimes it's also referred to as a data member. All right, it's a member of this class that contains data, so hence the phrase data member. Whereas these methods or operations declared inside the class are also sometimes known as member functions. They're functions that are a member of some class, and in this case the sphere class. So to begin with, we have here a sphere with no arguments and no return type. Notice that's the same name as the class. Ergo, this is what we refer to as a constructor. And in fact, a constructor that has no arguments is referred to as the default constructor. And what we'll do is basically use this to create a sphere with a particular default radius of 1. Then we have what's called an initializing constructor. Again, constructors do not declare a return type. This is special. There's special methods in that sense, special functions in that sense. And it's not void either, okay? Just because something's missing doesn't mean it's void. It means there is literally no return type here, all right? And this is reserved, that phenomena, if you will, is reserved for class constructors. In this case, we have an argument, and so we use the value of this argument to initialize the radius of the sphere itself, and hence we refer to this as an initializing constructor. In future examinations of C++ details, we'll see a better way to put both of these together into a single declaration. And then we have what's referred to as a mutator, if you will. This is a method that changes the state of the sphere itself. It allows you to change the radius of the sphere. And so state is basically the set of values stored in the attributes at any given time. And so we're using this to change the state, hence referred to as a mutator function or method. GetRadius is a simple method that will return the encapsulated radius. And as it does not mutate or change the state in any way, shape, or form, but merely gives you access to some information about the sphere, this is referred to as an accessor method. Accessor methods should be declared as const methods. You see the const keyword after the function signature here, the method signature here. Actually, the const is part of the method signature. And it's essentially saying that it's guaranteeing that we cannot, in the implementation of this method, do anything to change the state of the sphere. If we try to, the compiler is going to complain because we're claiming this is a const method, meaning we're not going to change the state of the class. And then we have some additional accessor methods here for diameter, circumference, and area, and volume. And notice all of these are not going to change the state of the sphere. They're simply giving us information about the sphere. We're accessing information about the sphere, albeit computed or calculated information, but nonetheless just accessing information. And as such, they should all be declared as const methods as well. Looking at the implementation details then in the sphere.cpp file, here we see how we gain access to the declaration of this class in the first place. We include, and notice the use of quotation marks and not angle brackets, it's essentially a relative reference to this file. And since they both reside in the same directory, I just need to specify the file name itself. So now we need to implement all of those methods that we've declared in the class declaration of the header file. First thing that we had was the constructor. So this is an interesting notation that you need to get used to here. Remember, we're defining here member functions. They're functions that are members of a class. And so what we have here is a reference to a class name, in this case sphere, and then this pair of colons is referred to as a scope resolution operator. And it's essentially saying that, hey, I've got this method called sphere, in this case a constructor, which is a member of the sphere class. So this is needed, this is all needed to uniquely identify what function it is that we're talking about, that we're defining here. And as indicated in the comments, all we're going to do here is set the radius to be equal to the value of 1. And that's all we need to do here. Once this is called, we have an object whose radius is 1. Same thing here, the initializing constructor. We have the sphere with a single argument method, and it is a member of the sphere class. So again, we got class, scope resolution operator, function name, right? And then we're doing our definition. And what we're going to do here is simply call the set radius, because that is a mutator that is used to change the value of the initial radius. And so we're reusing code here. And it is noted that we don't have to precede the call to set radius with the class name and the scope resolution operator, because we are in essence inside of the sphere. And so we can see all the things that are inside of the sphere, namely the set radius method. If we look at the setRadius method now, this is the first method that we have here that isn't a constructor, and therefore a return type needed to be specified. And so in our definition, that's what we do here. We have our, just like as always, it starts out with a return type, and in this case there is no return type, it's void. And we're defining something called setRadius, but it's not just a function unto itself, it is a member function. It is a function that is a member of the sphere class. And this is why we have to use this whole thing here to make sure we're referring to the correct function. And again, remember it had an argument called new radius. And so basically we only want to assign a radius, some new radius to this sphere if and only if it's greater than 0. It doesn't make sense to have a radius that is 0 or a negative value. So if that passes the test here, that the new radius is in fact greater than 0, we'll change our radius to be the new radius using an assignment statement. On the other hand, if that failed, right, you gave me 0 or something less than 0, well then I'm going to say, you know what, I'm just going to give you a sphere with a radius of 1. This is guaranteeing then that we never create a sphere that is in some funky state that doesn't really exist in the real world. Then we have our getRadius definition. Again, we have a return type of double. It's a member function. It's a member of this class. And it's an accessor method. So this needs to match what we saw in the declaration. And all we're doing here is returning the radius. And then we keep going with the rest of these. These are all pretty straightforward definitions that you probably learned in like 9th or 10th grade. The diameter is simply 2 times the radius. The circumference is 2 pi r is the way people mostly remember that, but 2r is in fact the diameter, so we have just a single multiplication going on here. Well, hidden, if you will. There's actually 3, but whatever. So it's pi times the diameter. And area is going to be 4 pi r squared for a sphere. That's the surface area of the sphere. And then finally we have the volume of a sphere, which is going to be 4 pi r cubed divided by 3, or 4/3 pi r cubed. And what we've done here on line 51 is simply create a new local variable called radius cubed, just so that this expression doesn't get too long and complicated to begin with, and it makes the code a little bit easier to read. So this is our definition of a sphere. Now we can extend this, i.e. specialize this, into what we call a sphere with color, or sphere in color. And so here, looking at the declaration of this new class, this is going to be a subclass of the sphere. And we're going to use an enum to provide some values for what the color of this sphere could be. And here is the way we extend a class, i.e. subclass, an existing class in C++. For now, just always use colon, and then public, and then the name of your superclass or parent class. In a few weeks, we will talk about the different values that this scope resolution operator can have when we're extending classes, and what ramification that has. Just as a, to clue you in, or give you a teaser here, this could be public, it could be protected, or it could be private. And again, we'll talk about those differences and their ramifications in the declaration in a future lecture. So this is saying then that sphere in color is a subclass of sphere. It's going to have all the attributes, or all the public methods and protected methods available to it directly that were declared and implemented in sphere. And beyond that, we're also adding another attribute here called the sphere color. This is going to be the color of that sphere. And so what we're going to do here is just declare a couple of additional constructors that we have, where we can create these spheres with an initial color, and maybe with an initial color and some initial radius. And then we have an accessor for the color. I'm sorry, a mutator for the color called setColor if we wanted to change the color of this sphere in color object. And then we have an accessor to get the color of this particular instance. And again, as an accessor, it's declared as a const method. And then we can take a look at the implementation details of this subclass. So we're including sphere in color to get the declaration of that class. And if we go back there for a second, you'll see here that I've included sphere to get access to the sphere, which is utilized right here. So that means if I pound include sphere in color.h, I'm carrying along a pound include sphere.h. So if I include sphere.h in some other file and sphere in color.h in some other file, you see how sphere can be declared multiple times within the same scope. And again, the need, therefore, of these macro guards. Back to the definition of sphere in color. So, same old song and dance. Our constructors, no return type. We're using the scope resolution operator to identify where these methods exist. This constructor is a member of the sphere in color class, and it has this argument here. And now this is something that we're doing here. This is called an initializer list. And what we're doing basically with this initializer list is before we can create a subclass of something, we have to build that something first. All right, so this is essentially calling the default constructor of its parent. And then once that parent has been constructed, we can, the basis of this class, if you will, has been constructed. Now we can go above and beyond that and provide the initial color for this sphere. Likewise here, with the initializing constructor, we will use this initializer list to call upon the sphere initializing constructor because we have an initial radius given to us. And so we'll use that to build the basis of this object and then go above and beyond and provide the color for this object as well. And then we have our set color, which is doing the same old song and dance with our mutators, and our get color using the same song and dance for our accessor methods. Now let's see how this is all used together. So if we take a look at sphere driver.cpp, I'm going to do some input and output, so or maybe just some output rather. Either way, I have pound include IOStream to get that access to those objects that I need. Then I'm including sphere.h and sphere in color.h, and this is exactly what I was just talking about, where given these two files now and the fact that sphere in color.h includes sphere.h, there exists the potential that the sphere class could have been declared twice in the same scope, and that's again why we have those macro guards. Now here I have what's called a function declaration. I'm declaring a function because I'm going to use it right here in main, and before I can use a function, C++ needs to know everything about some function that I'm about to use. So by having this declaration first, the compiler can say, this function is being utilized correctly. Now ultimately I'm going to have to provide a definition for that in order for this file to compile, but the point being is that what we often do is have our function declarations before we use them, and then later on we define them. This order is not required by any means at all. It's just a convention that's fairly standard. That is to say, I could have just provided the definition of that function right here and then provided the definition of main, and I would be good. I wouldn't have had the need for this function declaration. But it's nice to sort of see what's coming, how it's going to be used, and then how it's defined in that order. So what we're doing here is we're creating a sphere object called UnitSphere because this is utilizing the default constructor. UnitSphere will have a radius of 1. I'm creating another sphere object called MySphere, and I'm utilizing the initializing constructor. All right, and its sphere radius will be 5.1. Then on MySphere, I'm going to change it right away and change its radius to 4.2 by calling on the set radius method. Then I'm going to output the get diameter, so I'm basically calling one of its accessor methods. And then I'm going to show you how we could use a sphere in color object. So I call this method here, this function here, and so we come down here and I declare a sphere in color. It's named ball, and it's going to be initialized with the color red. At this point, it would be a sphere with unit radius 1 and a color of red. But I'm changing the radius to 5 by call the set radius, and then I output its diameter and set it or change its color to blue, so on and so forth. So this is just showing you, some usages of a sphere in color object. And now let's take a look at how we might compile this sphere driver class, or sphere driver template. That's not even a template, it's just a test implementation, if you will. So you might be tempted to think, oh, you know what, I can just do G++ sphere driver and be good to go. But that's going to fail. What's going to fail is that it has no idea. I mean, the program itself has made references to a sphere, references to a sphere in color, but it has not seen any implementation details codified, right? Put into binary form that can be linked together to create my executable program. So you say, all right, fine. Let me provide you with the details of the sphere. And since the sphere in color is built on a sphere, that should be good to go. Well, no, not quite yet. We still haven't provided the implementation details to the compiler about a sphere in color. So now we'll say sphere in color.cpp. And now we have, again, because we didn't use any of our command line switches, a program called a.out, which when we run is effectively this program. And you also see now how we go about compiling something that requires multiple files in their compilation. The header files are not included here because the CPP files actually include them. And so the declarations of all those classes are made known to the compiler through the implementation files, and therefore they're able to do what they need to do. And each of these individual files are compiled, and then the linker will join those object files together along with the stuff that is pulled in with IOStream and generate a final executable, in this case called a.out. And like before, we could add to this, if we needed to specify the fact that we want to compile against a particular version of C++, we could do that as well. And in fact, if we wanted to name the executable, we could do that as well. Now instead of a.out, I'm going to have a program called sphere driver. And now I can run sphere driver instead of a.out, and there we go. So there, we've taken a look at a class, a subclass. We've seen the separation of interface and implementation, and we've seen how to compile now a program that requires multiple files in the command line.